All right, so let's talk triangles here. So we're going to talk about some special right triangles, and there's two of them we talk about. And the first one's called a 45, 45, 90. And 45, 45, 90 is in reference to the angles inside the triangle. So imagine I have a square. Well, we don't have to imagine it. We have one. And I draw a diagonal in it. Both of these right triangles in here can be classified as right and isosceles, because if this is a square, all the sides of the square are the same, which would mean in the right triangle here, my legs are the same. So let's pretend for a second that in this square, all the side lengths are 5. So if all the side lengths are 5, and I look at this right triangle here, I have a 5 here and a 5 there, and I want to find the hypotenuse, I could say 5 squared plus 5 squared is c squared. 25 plus 25 is c squared, which gives me a 50. And then if I square root and simplify that, 50 is 25 times 2, which makes c 5 root 2. So if I have a 5 and a 5, I ended up with 5 root 2 for the hypotenuse. Now let's do the same thing, but let's say my square had side lengths of 8, so the legs of the right triangle are 8. And I'm going to do the same thing again. So I have another 45, 45, 90 because it's isosceles. And I do 8 squared plus 8 squared is c squared, which is 64 and 64. And that's 128. And 128 is 64 times 2. I know that because I just used 64s to get it. And c is 8 root 2. So I had an 8, an 8, and an 8 root 2. Well, that looks familiar. 5, 5, 5 root 2. 8, 8, 8 root 2. I think there's a pattern. There is a pattern. What you should notice is when you have a 45, 45, 90, you have one side length. The other side length is going to be the same, and the hypotenuse is that original one times radical 2. So when you have a 45, 45, 90, the legs are the same length, and the hypotenuse is that number times root 2. Now, I can do SOHCAHTOA on this as well. So if I do the sine of 45 here, doesn't matter which 45 I pick, if I do opposite over hypotenuse, I end up with s over s root 2. Well, my s's can cancel, which leaves me with 1 over root 2. Can't have a radical on the bottom, so I'm going to multiply to get rid of it. The sine of 45 is root 2 over 2. Well, if I then did cosine 45, cosine is adjacent over hypotenuse, so adjacent over hypotenuse is again s over s root 2. And we all know how that works out, the same way it did the first time, right? Because these are equal. And then if I want tan 45, it's opposite over adjacent, s over s, which is 1. All right, so what do I need you to know from this? I need you to know if you have an isosceles right triangle where two of the legs are the same and the hypotenuse is therefore different, if you know the length of each leg in a 45, 45, 90, then you just multiply by root 2 to get the length of the hypotenuse. Conversely, if you know the length of the hypotenuse, then to go backwards, you would divide by root 2 to get the length of each leg. Now, some people like ratios, some don't. It's completely up to you if you want to use this proportion. But if you want to use a proportion for a 45, 45, 90 triangle, you can call each of the legs in the 45, 45, 90 1, which would then make the hypotenuse root 2. And then this would be over leg, leg, hypotenuse. All right. So if I come down here and I want to use that, again, what you really need to remember is if you know that you have an isosceles right triangle that's a 45, 45, 90, you have two sides with equal length and a hypotenuse that's that thing times root 2. So if it says a high school softball diamond is a square, okay, good, and the distance from base to base is 60, and I want the distance from second to home, if I look at this, I have two 60s, which means this is an isosceles right triangle, which makes it a 45, 45, 90. S, S. D would be S root 2. Okay? And then same thing, if I have the diagonal of a square garden, and the diagonal has a length of 50, if this is a square garden, my legs are the same, making this a 45, 45, 90. I multiply by root 2 to get the hypotenuse, which means I need to divide by root 2 to get the length of a leg. So the length of a leg would be 50 divided by root 2, because I'm going backwards this time, which I'm not allowed to leave it like that, so let me fix it. That's 50 root 2 over 2. 50 divided by 2 is 25. So this is 25 root 2. We want the perimeter of the garden. Well, that's 1, 2, 3, 4 of those. So 4 times 25 root 2 is 100 root 2. Okay? Then we also have what's called the 30, 60, 90 triangle. And this one's important not because we can make it in squares, but because we can actually make this in in equilateral triangles. If I have an equilateral triangle where all sides have length 2s, all the angles would be 60. So this is 60, that's 60. But then if this is 60 and I drop an altitude, that makes this 30 degrees as well as that one. And right here, I have what we call a 30, 60, 90. Well, if this was 2s and I drop an altitude and an isosceles, it cuts that guy in half, which gives me a short leg of s, a hypotenuse of 2s, and now I need the longer leg. So I'm going to use the Pythagorean theorem here to find the longer leg. So I'm going to have a squared plus, I'm going to call this the height. So h squared equals c squared. So a squared plus b squared equals c squared. This would be s squared plus h squared is 4s squared, because 2s squared is 4s squared. And then subtract s squared and have h squared equals 3s squared and square root it. And I'm going to get h equals root 3 times root s squared. But root s squared is just s, so h is s root 3. That makes this height s root 3. Wait, Mrs. Vibber, I didn't follow all of that. That's okay. I'm just going to draw it one more time right here. So in a 30, 60, 90 triangle, the side across from the 30, the side opposite 30, we call s. The hypotenuse is 2s, it's double that, and your height, your side across from 60, is s times radical 3. It's just like the last one, except now instead of my legs being equal, one is an s, the other is s root 3. So now that I know that and I want to find the sine, cosine, tangent of these values, I can just look at this triangle. So the sine of 30 would be opposite over hypotenuse from 30. So the opposite would be s. The hypotenuse would be 2s. And my s's cancel to give me 1/2. And then if I want sine 60, I do opposite over hypotenuse from 60, which would be s root 3 over 2s. The s's still cancel, and I get root 3 over 2. Cosine 30 would be adjacent over hypotenuse from 30, which would be s root 3 over 2s. S's cancel, I get root 3 over 2. Cosine 60 adjacent over hypotenuse is s over 2s, or 1/2. Tan 30 is opposite over adjacent. Opposite 30 is s. Adjacent to 30 is s root 3. That makes this 1 over radical 3, because remember, if you cancel everything from a side, technically there's a 1 left behind. So I have 1 over root 3, but that's got a radical on the bottom I need to get rid of. So that's root 3 over 3. And then tan 60 would be opposite over adjacent. S root 3 is opposite now, and s is adjacent. Technically, that leaves a 1 on the bottom, but root 3 over 1 is just root 3. Okay. But long story short, if you have a 30, 60, 90, you have the smallest side across from 30. We call that S. We multiply by that by radical 3 to get the side across from 60, and we double it to get our hypotenuse. So if I know the length of the short leg, then I multiply by 2 to get the hypotenuse. And if the hypotenuse is known, I divide by 2 to get the short leg. So short leg to hypotenuse, you double it or divide it in half. If you want to go from short leg to long leg, if you know the short leg and want the long, you multiply by root 3. And if you know the long leg but want the short, you divide by root 3. And we can make a proportion out of this one. If I have a 30, 60, 90 triangle, I have sides of 1, radical 3, and 2. And then those sides correspond with the short leg, the long leg, and the hypotenuse in my proportion. All right, so we're going to just do a couple quick practice exercises. And then for the next one here, we've got find the value of each variable in simplest radical form. So I look and I realize, oh, this is a 30, 60, 90. So in a 30, 60, 90, wherever you decide to put the 30 and the 60, it's up to you. The side across from 30 is S. The hypotenuse is double that. And the side across from the 60 gets a root 3. So in this case, my hypotenuse is 8. The hypotenuse is double the shortest side, which makes my shortest side 4. And the side across from 60 should be that short side times radical 3, making this 4 root 3. And if you're like, whoa, Ms. River, there was way too much going on there, this is a good case to do that proportion. So 30, 60, 90, 1, root 3, 2. And yes, you have to remember where they all go if you're going to use this. But I know the side across from the 90 is 8. The side across from the 60 is Y, and this guy's X. So I'll start with this pair and say 8 root 3 equals 2Y. Divide by 2. Y equals 4 root 3. And hey, look at that. That's what I had for Y. And then if I use these, 1 over X equals 2 over 8. 8 equals 2X. X is 4. Hey, look at that. That's what I had before also. So you can either use the picture of the triangle or you can use the proportion, all right? So let's try it here. The longer leg of a 30, 60, 90 triangle is 6. Okay. So 30, 60, 90. The longer leg would be across from 60. So that's 6. I want the length of the hypotenuse. Let's use the proportion again. 30, 60, 90. 1 root 3, 2. Let's see. The side across from 60 is 6. The hypotenuse is across from 90, and X is across from 30. I want the hypotenuse, so I'm going to solve that proportion. Y root 3 equals 12. Divide by root 3. I get, let's see, Y equals 12 over root 3. But I'm not allowed to leave it like that. 12 divided by root 3 needs to be multiplied by root 3, so there's no radical left on the bottom. 3 goes into 12 4 times. 4 root 3. There you go. There's the hypotenuse. Okay. And then I am going to save this chart for class because this will be a good jumping off point for us to keep moving. So there you go. Done, done, done. I need a joke. Oh, I had a good one the other day, and now I don't remember what it was. The joke I'm going to tell you is, where do pencils go on vacation? Pennsylvania. Oh my God, it's so terrible. I have to think of a better one. I'll think of a better one and tell you in class tomorrow. All right. Bye.